Hello, guys.
Hi.
Hey
Hello.
there.
You know, I
Hey,
saw
everyone.
I saw you all this week already, but it feels like a reunion.
Yeah, I
So,
noticed a few of us are in the Nellie's Observatory, but
At
but
least it
not.
looks that way.
we're all virtual because Nellie is closed up because it's snowing up there.
That's right.
And,
Believe it or
and
not, this doesn't happen very often, but it happens once every couple of years where we actually get snow in the Oakland Hills. So,
And
it's kind of
Chabot is up at 1,500 feet, so it just has to get that low.
Well, I tell you, the
See it.
observatories are at 37 degrees. So this is one of those days I'm happy to be home.
That's right.
yeah,
So let's introduce everybody. So my name's Rich Ozer. We have Gerald McKeegan, and we have John Curry, John Wave,
Hi.
and Rick Taft.
Right.
And we're all here for our virtual telescope viewing night. And
Yeah.
sorry we can't be operating the real telescope, but we'd only have clouds to show you. Before we get started, I want to thank the staff at Chabot for making this event possible tonight and working hard to publicize it. We already have over 150 people watching tonight, and so you've done a great job. Thank you very much. I want to point out to our viewers that if you're watching on Facebook, there should be a button at the bottom of your screen to help support the Chabot Space and Science Center. We rely on donations from the community, and we'd appreciate yours for sure. So that's it for the commercials. But why don't you guys dig up that picture of the snowstorm at Chabot from today,
Yeah.
and so we can show people what snow in Oakland looks like.
Yeah.
You got
I'm
one
sure
there,
I'm sure people from cold climates will kind of laugh at this.
Oh, it's a total joke if you're from
Yeah.
a cold
Yeah.
climate.
But you have to realize this doesn't happen in the San Francisco Bay Area very often.
You got that picture, John?
Well, John's having sharing
Yeah, I don't want to try
challenges.
that because every
Yeah.
time I do that, my
Okay.
Zoom.
So you want me to find it, huh?
Oh, yeah. Well, if you don't find it, that's okay. We
Yeah.
can move on to other things.
Actually, I have found it. Stand by here. Yeah, here we go. And all right, can you see it?
There we go.
Yeah, there we
Oh,
go.
yes.
So
Careful where you step. You may slip a few inches.
yeah, so you can see a couple of the observatory domes in the background here. This is some steps out on the observatory plaza. Now, for the folks that are back east or anywhere where it snows normally, you're saying,
Please
big
excuse
deal.
us. That's right.
So, for us, this is a big deal.
Yeah,
So
we feel for you back east where you've got all
Oh my
those
God. Yeah.
horrible
all right.
snowstorms.
Okay, so enough of that.
All right. Well, why don't we get started? I think Gerald, you're first up with our talk about the Green Comet.
The Green Comet, yes. Well, some of you may recall that there was a lot of news about a green comet in the air or in the sky a couple of weeks ago. All the astronomers were kind of scratching their heads and saying, well, what's the big deal? So what if it's green? Comets are often green. But we did have a green comet. Contrary to what you may have read, it was really not a naked eye object. You had to be in a really, really dark place to be able to see it naked eye. This was the comet called C/2022. What was it? E3, I think it was. And also known as ZTF.
ZTF. Yeah.
And that comet was just one of many comets that come into the inner part of the solar system from way out in what's called the Oort cloud. The Oort cloud is way out at the very fringe of our solar system. There are a lot of icy bodies out in the Oort cloud. Every once in a while, one of them gets knocked loose. by a collision with another one of the icy bodies out there, or maybe an interaction with a passing star or a passing cloud of gas and dust. Something causes it to drop out of its normal orbit and fall in towards the sun. And when that happens, we get a comet.
Hey, Gerald.
Yeah.
How about if you mention where the name comes from, the ZTF in particular?
Okay. ZTF. There's a couple of different ways of naming comets. If a comet is discovered by an individual, or maybe one or two individuals, the comet will be named after that individual. So there's Temple Tuttle, named after two guys. One's named Temple and one's named Tuttle. But you can also name it after the observatory. If it's discovered by an observatory where a lot of people are working, rather than having a whole bunch of individual names, they just name it after the observatory or the observing program that discovered it. So ZTF stands for the Zwicky Transient Facility. It's a program at the Palomar Observatory in Southern California. They are looking for transients, typically supernova explosions and things like that. Something that happens for a short period of time and then disappears again. That's called a transient. So they're the ones who discovered this object. So that's why it's called ZTF. You may recall a few years ago, actually it was in 2020, we had Comet NEO-WISE. The WISE spacecraft was a satellite that was doing observations. It's an astronomy satellite. And it had a part of its program or a follow-on program where it was used to search for near-Earth objects, hence the name NEO-WISE. And it discovered that comet. So that was Comet NEO-WISE. So it can be either named after individuals or named after observatories or observatory programs. So that's where the name came from.
And the other part of that is the C3/2022 E3.
Right, which is the official designation.
Right.
When you look it up in official catalogs, it's got a much more much less interesting designation. In this case, it was C/2022 E3. The C means it was a comet, and it specifically means it's a comet from the outer parts of the solar system. There's another comet designation, which is a P, and that means it's kind of an inner solar system comet. This one is from the outer part of the solar system, so it had a C/2022, the year of its discovery, and then the letter and number refers to the time of the year and the sequence. So we use what's called a half month format. So if it's discovered in the first month of or the first half of January, it's an A. If it's in the second half of January, it's B. First half of February, it's C. Second half of February, it's D. This one is an E. So it was discovered in the first half of March of 2022, and it was the third comet discovered during that half month. So that's where that fancy number. There is yet another designation which compresses this even more, but we won't get into that. So that's only for the computers. So anyway, we've got some images. I don't know if you guys want to share, or if
why don't you share? Why don't you share the first one? Because you have the high resolution version of it.
Okay. So this is an image taken by Tara. You have to help me with the pronunciation.
Mostafi.
Mostafi. Yeah. Okay.
Yeah.
She took this. She went out to Yosemite to take this image because they had much better skies in Yosemite than in the Bay Area. She's actually a Bay Area amateur astronomer, a member of the Mount Diablo Astronomical Society. She took this really great image that she had, and this shows the comet. Now, you notice that it has some green to it, hence the term green comet. It turns out that it's very common for comets to have a green color. The comet nucleus is composed of ices. Those ices can be many different types of ice, not just water ice. It can be methane ice. It can be cyanogen ice. It can be carbon dioxide ice, all kinds of different kinds of ices. And some of those ices are made up of carbon compounds. And when the right combination of carbon compound sublimates, which means the ice goes from being a solid to a liquid, it releases it goes from solid to a gas. It releases these carbon compounds as gas, which surrounds the nucleus of the comet and is then hit by the solar wind and ultraviolet radiation from the sun. That ionizes the gas. And when you have certain carbon compounds that get ionized like this, it produces a green glow. So it turns out this is actually pretty common. A lot of comets have a green color to them, which is why all the astronomers, the professional astronomers, were scratching their heads and wondering why all of a sudden this one is such a big deal, because lots of comets are green. So there's an interesting thing about this image, though. You see two tails, one kind of going off, and this one kind of a narrow, very straight tail. And then there's another tail that's kind of fan shaped like this. And there's some interesting science behind that. So I wanted to maybe share a little bit with you about why that is. So I'm going to stop the share here for a second and then see if I can find this other one. Okay, here it is. Okay, so this is an image from another comet. This one has a blue tail rather than green. This was taken by Wesley Chang, who is a member of the East Bay Astronomical Society, another Bay Area amateur astronomer, and he's a really good astrophotographer. But anyway, this shows the comet, and you notice there are two tails, this long, straight, in this case, bluish tail, and then a much more diffuse kind of fanned out tail that's kind of white in color. These represent the gas that was released by the comet. That's what the long, straight tail is. The gas is the ice that sublimates. It changes from solid to a gas when it gets close to the sun. And that gas then streams away from the head of the comet as this long tail. That tail always points in the opposite direction to the sun. So I've put the sun right here. And so you can see that it's extending out in the opposite direction. And it's driven that way because of the solar wind. Embedded in all of that ice in the comet is a bunch of little particles, rocky particles, pebbles and grains of sand, and sometimes bigger rocks. And as the ice sublimates, it releases all this particulate material. That material, being heavier, is not so much influenced by the solar wind, but it does kind of trickle behind the comet as a kind of a tail that follows along in the direction that the comet is going, or actually in an opposite direction. It sort of follows the orbit of the comet. Now that can cause some interesting effects. So I'm going to see if I can advance this here. Bear with me. That worked. Yeah. So here's a presumed path of the comet as it approaches the sun. And here's the comet at a later position. And you'll notice that now the opposite direction of the sun would push the gas tail in that direction. But the particle tail still sort of fans out along the path of the comet. So it would do that. So now you notice you've got a lot more angle between the two tails. So here's a pretty small angle here. As it gets closer to the sun, it gets even larger. It gets really interesting after the comet swings around the sun. What happens is it comes from way out in the outer part of the solar system. It comes in and it swings around the sun and heads back out. So what happens when it starts to head back out? So here we are on its path going outbound, and here's the gas tail. Remember, it always blows away from the comet head opposite the direction of the sun. But that particle tail still is spread out along the path of the comet behind the comet. So the particle tail ends up like this. So now they're going in opposite directions, and we can actually see that sometimes. That image that I showed you a minute ago, I'll go back to that. This actually is kind of halfway in between. It's already on the outbound leg. She took this photo, I believe, on January 30th, and it was around the 15th of January when the comet went around the sun. So it's already on the outbound leg, and you're already getting a separation of that, those two tails. It just happens to be that the path of the comet is kind of going away from the Earth as well as the sun. So it looks like the fan of the particle tail is blowing right toward us. And that's very common. We'll later on, we would be able to see two tails actually going in opposite directions. Very common for that to happen. Now, this is a nice picture, nice close-up picture, but she also took another picture I thought was really great. I think you've got that one, Rich.
I
right?
do. Yeah, and before I show that, though, I want to mention, everything in astronomy is seems to be related at some level, and that particle tail that you were talking about is what contributes to our most notable meteor showers.
Yeah.
So when that particle trail intersects the Earth's orbit and leaves a bunch of rubble in our orbit, every time we pass through it, we get a meteor shower.
That's right.
And it lasts, year after year after year, because there's always, so much material left behind that it puts on a show every year and into the future.
Right. But that's only if that particle tail happens to cross the Earth's
Exactly.
orbit.
Yeah.
Most of the time, a comet's orbit does not intersect the Earth's orbit, so you don't get that. But every once in a while you do, and that's when we get those meteor showers.
Yep. Let me find that other photograph that Tara had done.
While you're looking for that, Richard, I want to mention a comment on YouTube. We've got a youngster named James.
Hi, James.
I'm sorry. His name is Nolan, and he's 6 years old.
Hi, Nolan.
Wants to know if we can recommend some cool space groups or programs that his parents can look into for him. I would say, come on up to Chabot Space and Science Center.
Yeah.
We're easy to find. We're up off of Skyline Boulevard, 10,000 Skyline Boulevard in Oakland. And most GPS things will find that very easily for you. And it's a great place to come visit.
Yeah. We're assuming Nolan lives in the Bay Area.
Well, he says he's in the Bay Area.
Okay, that's good.
Yeah.
All right, that works.
Otherwise, you might be sending him on a long trip.
Commute.
That's right. Yeah.
But don't come up tonight. It's snowing.
Right.
Yeah, it's snowing. No space tonight, except on our video here. All right, so this is another photograph that Tara took, and it is a variation on landscape astrophotography, and this is one of the notable waterfalls in Yosemite Valley with the comet overhead. And this isn't a single shot. You're not going to be able to walk into Yosemite Valley next comet and just take one snapshot and expect to get something like this. There's a whole process involved in getting enough exposures of the comet and stacking them, and also taking a long exposure of the geology, and then combining the two together in order to get this type of landscape. But anyway, she did a beautiful job on this, and last week it was the astronomy photograph of the day, which is a daily photograph of astrophotography that is picked by a group in Southern California. And I think this is her second APOD.
It is. It's her second APOD, And if you would like to see this actually was posted on February the 21st, so just a couple of days ago. But if you go to apod.nasa.gov, apod.nasa.gov, you'll see the current APOD of the day, and then you can click on a link at the very top of the page that says Discover the Cosmos, and you'll see a whole list of these amazing photographs from not only amateur astronomers, but professional astronomers as well. So I would encourage you to check out the link, and if you guys can put that in the, or Rich, if you can put that in the chat, that would be great.
It was apod.nasa.gov, right?
Yeah, apod.nasa.gov. And you know, what was interesting on this photograph, as Rich was saying, it's not a simple walk up and take the picture and you're out of there. Tara had to bring a tripod, sky tracker, of course, a camera with telephoto. And the image actually is a composite image of the foreground being lit by the moon. And actually it looks like a daytime image because the moon is reflected sunlight. And so a long exposure for the landscape and the waterfall, and then a series of shorter exposures for the to actually capture the comet. And then with a lot of post-processing, you wind up with an amazing image like this.
Yeah. So I've got one more comet image before.
I actually have a couple more as well. So go ahead and show yours, Gerald, and I'll.
And Gerald, before you show this, I got to mention one thing. When Tara was done taking this image, she was all by her lonesome out there in the wilds of Yosemite. On the way back to her car, this little black furry thing scurried right in front of her, almost right over her feet. It was a little bear, and she was wondering, where is Mama Bear?
That's exactly the right question to be asking.
Right.
So
Mama Bear was gazing at the comet, didn't realize what was going on.
Right. Don't bother Baby Bear.
Yeah, sure. Yeah. So I got one more comet picture, and then we can kind of move on to other subjects here. But here's another image taken by a guy named Dan Bartlett. This was also on APOD, by the way. And this was a few days after Tara's image. And you can see that as the angles have changed now, the two tails are actually almost superimposed on each other. So this huge fan-shaped thing is the dust particle tail, and then you can see the long straight tail of the gas that's kind of blowing away from the sun. So just another angle and illustrating what I was talking about with the tails that can sometimes get very much opposite each other.
Opposite ends, yeah.
Yeah. So
I've got a couple more I just want to show real quick, and we'll just take a second. This is another one from one of our Bay Area astronomers who is a member of the Mount Diablo Astronomical Society. It's Jim Hahn, and he took this one before Tara's, and I do have one other from him as well. And this one, you could really see the green. Brought that out really well. Anyway, that was it. Thank you, Jim.
Yeah,
Okay.
didn't Jim take that from his backyard?
Yeah, I believe so. I believe he did.
But he's using not just a camera, but a telescope.
Right.
And right. Yeah.
So I'm going to give a quick shout out. We've got on a YouTube, another 5-year-old YouTube watcher named Lorenzo, and he wanted us to say hi. Hi, Lorenzo.
Hi, Lorenzo. He didn't have any questions, huh?
No questions. He just wanted to say hi.
Well, hi. Okay, well, we got other topics to talk about tonight. For those of you tuned in late, unfortunately, it is snowing up at the Chabot Observatory, so we are not able to actually look through our telescopes, but we got lots of astronomical things to talk about. You want to do the asteroid?
Yeah.
Yeah.
All right. Okay, well, some of you may have heard about this. Earlier in February, around February 12th, astronomers spotted a small asteroid headed right toward the Earth. And we had only 7 hours notice between the time it was first spotted by an observatory in Hungary and the time when it entered the Earth's atmosphere. And I thought it'd be interesting to kind of talk a little bit about that. There is a global network of observatories, one of which is that one right here over my shoulder, that are involved in searching for and tracking near-Earth asteroids. And it is very common for us to not discover those near-Earth asteroids until they get kind of close to the Earth. And in this particular case, a observatory, this was a professional observatory in Hungary, was scanning the skies, and they spotted something moving. Didn't think much of it at first. Took the data from their images. They had 3 or 4 images that they were able to get of it, and submitted their data to the International Astronomical Union's Minor Planet Center, which is in Massachusetts. The Minor Planet Center is the global clearinghouse for all of the asteroid data that is collected by all these different observatories in this global network. They posted it on a website that says, hey, somebody saw something out there. We need confirmation and follow-up imaging of it to try to characterize its orbit and what kind of asteroid it is and so forth. It was put up on that site. A short time later, another observatory in Croatia was able to find it. They got some more data. And within an hour of the first observation by the Hungarian observatory, an amateur astronomer in England, a guy named Peter Birtwistle, who's also a part of this global network, he started taking the data that had been collected so far, started crunching the numbers, and he came up with an interesting fact. He realized that this asteroid was going to hit the Earth, and it was going to hit it within 7 hours. So the original observation was made at 8:18 p.m. 2018 Universal Time, which was about 12:18 p.m. Pacific Time where we are. And they realized that about 2:59 in the morning Universal Time, which was still, I think it's like 7:59 our time, it was going to impact the Earth. And they were able to figure out about where it was going to come down. So I want to kind of share that with you. This is northern France that you see here. This is the English Channel right there, and that's England over here. These are the Normandy beaches right here where the D-Day invasion was. In fact, this whole region here is the Normandy district of France. And the initial indication was that this asteroid was going to come down somewhere in this region right here.
And Gerald, I'm not seeing your screen. Is this going
No,
up? Is everybody else seeing this?
I'm seeing it.
I'm seeing it. Yeah, it's going up.
You and Zoom just aren't getting along, John.
Yeah, I know. It's this new version, I guess.
Yeah. So anyway, with somewhere within this oval was where it was going to come down. Immediately, lots more observatories jumped on it. As soon as Peter Birtwistle sent this email out to the network and saying, hey, this thing looks interesting, it might be an impact, immediately all these other observatories started taking a look at it. We ended up actually with hundreds of observations out there. I can just kind of give you an idea what that looks like. I'll share that image with you. This is just a partial list of all of the observations that were taken within just a couple of hours after that initial observation. And they use this to figure out where it was going to come down and when it was going to come down.
I want everybody to copy all those numbers.
Yeah,
Make sure you get
There'll
there.
be a test at the end.
Yeah. I've got one other image here. Let's see, where is it? Maybe I don't have it. Oh, here it is right here. So I mentioned that there's some software that they used, and I just wanted to show you the readout that he got. And here it is right here. So all of the data that was collected by all these observatories was plugged into this software, and the software then analyzes it and comes up with an estimated orbit and tells us whether or not there's going to be an impact. And if you look right up here, you see the word impact.
Impact.
And that's what got everybody's attention.
Yeah.
And here are the coordinates where the impact was expected to occur, and that corresponds to that oval that I showed you. And in fact, 7 hours later, that's exactly what happened. Try one more time here.
I noticed how they put the word impact in all caps.
In all caps. That's
Right.
right.
You know, it might be something
You know?
important. So this is where it entered the atmosphere. I'm assuming you guys are seeing that. That's where it entered the atmosphere.
Wow.
And of course, the next day, swarms of people were out there looking for bits and pieces of it. It entered the atmosphere here. It was about 50 kilometers high at that point and continued on. This was the path it was following. As it entered the atmosphere, it broke up, it burned up, but bits and pieces of it fell on the ground along this path in France. And the very next day, swarms of people, literally international teams of people, descended on France looking for meteorites. And they found some. Let's see here.
I think we mentioned before this was a second Normandy invasion, right?
Yeah. Let me share one more image here.
Uncontrollable astronomers.
Yes.
Yeah. So because we knew what time it was going to come down, several people went out with their cameras and actually got images of the asteroid as it entered the atmosphere, burned up in the atmosphere. And this is one of those images. And like I say, the next day, swarms of people were out in the fields of France looking for bits and pieces. Here is a young graduate student, part of a research team. She and the rest of her team wandered around out in the field, and they began to find meteorites. She's pointing, it's probably hard to see, but there's actually a little bit of a hole in the ground. This thing hit the ground pretty hard, and it punched a hole in the ground. And in the bottom of the hole, there's a meteorite. That's what it looked like after they pulled it out. The reason they wrap it in tinfoil is because they don't want to contaminate it with oils from the hand. That would spoil the analysis of the meteorite. So she was part of this team that was very lucky. There's another guy. His name is Steve Arnold. And some of you may be familiar with Steve Arnold. He and another fella used to have a TV show called The Meteorite Men. And in their TV show, they would show these two guys wandering around all over the world looking for meteorites. Well, Steve Arnold, of course, was one of the guys who immediately rushed to France to see if he could find one. And there he is. And you see, this is somebody goes, dude, there's something in this hole, right? So he's pointing to a hole right there. And that's where he...
I'm thinking snake, not meteorite. Myself.
So this is Steve Arnold. And of course, he found a meteorite, and that was cause for celebration. So later on, he took a picture of his meteorite sitting next to his celebratory glass of champagne right there. Of course, when you're in France, you got to have some champagne, right?
Absolutely.
So anyway.
So Gerald, now let's take a close look at that meteorite. How would an untrained person recognize a meteorite from a rock?
Oh, well, I'll tell you what, let me pull this back up here. There are a couple of clues, and it actually depends on the type of meteorite. So here's a close-up of one of these meteorites. One of the first clues is the appearance of it. It looks to you like a rock, but what we actually see is a dark coating on the outside of the rock called a fusion crust. Now, in this case, one of the clues that they had found something was it was in a hole in the ground, surrounded by clay dirt, and here's this little rock embedded in a hole in the clay. So that was a pretty good clue. But one of the things you can do is to cut into this rock, and you'll see that there's a completely different rock on the inside. It has a fusion crust. All that heat that is produced when it enters the atmosphere fuses the outer layer of the meteorite, producing what's called a fusion crust. There's some additional things you can do. Contrary to popular belief, most meteorites are not iron meteorites. Most of them are what we call stone meteorites, or different classes of stone meteorites. They will have look more like a silicon rock, the kind you'd find out in the desert or something like that. But they have some interesting objects embedded in them. Quite often they have what are called chondrites in them. Chondrites are remnants from the very beginnings of the solar system. When the solar system was first forming, things were very hot near the sun, and there was little bits and pieces of material that were getting cooked by the sun's heat, fused together, formed tiny little particles that kind of just was a spray of particles orbiting around the sun. Again, this is 4.5 billion years ago. Eventually, that material got sort of embedded in other rocky material and condensed to form a solid rock. And so we call those chondrites. There are other types of crystals and materials that you can find. There's something called calcium aluminum inclusions. These are all things that meteorite experts know what they are, know what to look for. And that's why they're so interesting, because, not only do meteorites have some value, but scientifically they have value because they tell us a lot about the beginnings of our solar system. They hold remnants from the very beginnings of our solar system. So I hope that answers the question. Of course, if it is an iron meteorite, or if it's a stone meteorite that has a lot of iron in it,
It's heavy.
It's heavy and it's magnetic. So a lot of meteorite hunters, you'll see them walking around with a little magnet on the end of a stick. And when they see something that looks suspicious, they'll hold it. And if it's magnetic, that's a good clue that it's a meteorite. All right.
Well, that was a lot better than
Excellent.
my answer, which was like, it's a meteorite if it's surrounded by aluminum foil.
Right.
Yeah. So,
Okay, I have one more quick shout out. This one
Okay.
of more personal nature. I have 2 grandkids, Nicholas and Natalie, who are also watching tonight. So I just want to say hi to them.
oh, hi, Nicholas and Natalie.
Hi. And
Let's all say hi to him.
Colleen asks an interesting question. Well, this was, I guess, just a repeat. How big was the initial again?
Oh,
So it
yeah.
was between 1 and 2 meters, I think. Is that what you said?
Yeah,
Bill?
yeah. So somewhere around 3 to 6 feet in size. So a very small meteorite. And it turns out that most near Earth asteroids are very small. Most of them are smaller than 10 meters. 10 meters sounds pretty big to you. That's about 33 feet. But meteors or asteroids that are that small, when they enter the Earth's atmosphere and become a meteor, they burn up and break up long before they hit the ground. So the best you can expect is to find a lot of little pieces of it on the ground. By the way, just to a lesson in terminology, when a rock is out in space, it's either an asteroid if it's big. If it's small, it's a meteoroid. When it enters the atmosphere, whether it's an asteroid or a meteoroid, when it enters the atmosphere and you see it streaking across the sky, it's a meteor. And when you find a piece of it on the ground, that's a meteorite. All right. So as usual with astronomy, we like to come up with a whole bunch of different terms and confuse the heck out of people.
So
We'll add that to the quiz at the end of the show
Yeah.
too. Yeah.
Along with the numbers, yeah.
where does the shooting star come in? I wonder.
Ah.
Well, Shooting stars are actually tiny little chunks of rock. There's lots of them out there. They're floating around out in space, and every once in a while, one of them enters our atmosphere, and you see a very quick, bright streak of light. Actually, not as big or bright as that image I showed you a while ago. These are usually very fast and very, you know, I don't want to say faint, but they're not nearly as bright as that one was. And we see those all the time. Those are called sporadics, and you get several of them every single night. In fact, there are estimates that somewhere between 40 and 100 tons of rock fall on the earth every day. And most of them are little tiny things the size of pebbles or even grains of sand that fall through the atmosphere. They burn up in the atmosphere, and you see it as this quick, bright streak of light across the sky, and everybody calls it a shooting star.
Very good. Hey,
All right.
I've got a question from Facebook here. If we have a moment.
Yeah, for sure. Go for it.
Yeah. So Karen asked, what type of camera or telescope do you need to see comets or stars? And I know I'll put that up to the group here. I mean, one of the first things I would say to see stars is simply walk outside on a nice clear night. But what do you guys think? What type of camera, or pardon me, telescope?
Yeah, that's kind of a,
do you need?
you know, to just see stars, like you say, you can see stars naked
Well,
eye.
I think the question's probably more to see the comet. So to see the comet, you know, occasionally we're going to see them naked eye if they're bright enough. But in order to get a photograph, what type of camera or
a lot of it depends on where you're going to be, you know, because I mean, we saw some examples tonight. Tara was able to get amazing photographs using a camera with a lens, right, and putting it on a tripod. If she had tried that same technique here in Oakland, it would not have been anywhere near as good.
That's
too much light pollution. And for the other shots that we saw, they involved, in order to overcome the light pollution, it involved hooking up a camera to a telescope, because the telescope acts as somewhat of a, you know, mitigation for the light pollution, right? Because you've got so much additional aperture, it makes up for it. So there's not a single answer to this. A lot of it has to do with where you want to do your photography. But to get started, I tell everybody who wants to get started that, you know, first of all, photographing comets is not easy.
No.
It's one of the harder things to do in astrophotography, which is why we're all so proud of Tara, because it's like a year ago she wasn't even doing this, and then now she's like a master at doing it.
Like,
and it's not easy. But the way to start is to photograph the moon. And you could do that with a camera on a tripod. You could do that with a cell phone and a telescope. You can do that with a camera on a telescope other than a cell phone. And so whatever equipment you have laying around, you could start to practice and see the limitations of what it is that you own, and decide whether you want to pursue it further.
That's really a great recommendation, because the moon is so bright that it's an easy thing to photograph.
And you photograph it when it's a partial moon, not a full moon, but a partial moon, so you can see, you know, some relief in the mountains and see some shadows in the craters.
Yeah. Now, if you're specifically targeting or want to take images of comets, it also depends on the comet. You know, the green comet was actually not truly a naked eye comet. It was a little too faint to be naked eye unless you were in a really dark location. But you may recall a couple of years ago when Comet Neowise came around, that was a naked eye comet. If you went outside and you knew right where to look, you could see it with your naked eye. And taking pictures of it was pretty easy. I took several pictures of it, just putting a tripod out and taking about a 20-second exposure just with a digital SLR camera. And got the comet. And that's not a bad way to go, just to take short 10, 15-second exposures just with a camera of the sky, you can actually get some pretty good images, even in light polluted skies. So you don't need a lot of fancy equipment. People always ask us, well, what's a good beginner telescope? We always say a good beginner telescope is a pair of binoculars, because that helps you learn your way around the sky and you can see a lot more. If you want to get a telescope, a nice inexpensive telescope that gives you pretty good images is a Dobsonian telescope, like a 6 or 8 inch Dobsonian telescope, a great telescope for beginners because they're relatively easy to set up and use. And they give you pretty good quality images when you're looking through them. The downside to them is that they are not tracking telescopes. So you have to learn how to keep nudging the telescope as the Earth rotates and causes whatever you're looking at to move out of the field of view.
But the upside on those is that it won't empty your bank account either.
Yeah, right. Yeah.
Or not as fast. Yeah.
Yeah. That's one of the things you got to understand. This is one of those hobbies that if you get into it, it doesn't nickel and dime you to death. It 50 and 100 you to death.
Right.
But it is less expensive than owning a boat. So let's
Yeah,
leave
it is.
at that.
For sure that.
To
Or
start
an
with,
airplane.
that is.
Yeah.
But
Yeah.
one of the things I'd like one of the things I'd like to recommend is if you are considering purchasing a telescope, come up to see us at Chabot on one of our Friday or Saturday nights when we have free public viewing. And it's weather permitting, obviously, so we're not going to be there tonight or probably Friday night, maybe not Saturday night, but it's a good place to come up and talk to other amateur astronomers who can answer your questions. Gerald mentioned Dobsonian telescopes. We have probably a half dozen Dobsonians in one of our observatories that you can look at. And frequently we have one or more of those set up on the deck outside so you can actually view through it. So
I'm sure Richard's going to jump in on this, but
Friday night too.
Friday night is a great night to come up because we have the Telescope Makers Workshop up here at Chabot.
Yeah,
that's right.
Build your own.
Yep.
And Richard, how long has that Telescope Makers Workshop been going on?
It's been going on for at least 75 years.
Right.
Yeah, did it start in 1947 or something like that?
It was even before that, I believe. I don't remember the exact date. Yep.
So if you're a do-it-yourself type person, this is your opportunity to come up, take a look at what a Dobsonian telescope looks like. You can see how it's constructed, and if you are so moved, you can actually make your own telescope, grind your own mirror. And as Rich mentioned, we have people who have been doing that for over 75 years here.
Yeah, they started 75 years ago, and they're still at it.
That was that one guy that was working on a 36-inch like the telescope behind me here.
So I had another topic. I don't know if you guys are up for it. I wanted to talk a bit about how some of these subjects we've been considering tonight have been overhyped somewhat by the media. I'm a big consumer of news. Right, I read a lot of news, but I have very little tolerance for crazy headlines. And I want to point out a couple of things I noticed during this Comet period and afterwards. And this was a fairly typical headline. I don't remember. This was from one of the major. I cut out who the publisher was. I didn't really care to embarrass anybody. But this was a typical headline. Bright green comet dazzles as it passes Earth on 50,000-year journey. All right. So honestly, most of this headline is wrong. I mean, part of it is right. First of all, it was not bright. It was green, but they mentioned green because they're trying to portray it as something unusual. And as Gerald mentioned, most comets are green, and they all have that same chemistry. so there's always some green. It did not dazzle unless you were an astrophotographer,
Right.
and even then, it took an awful lot of work to get the dazzle out of the photograph. And the 50,000-year journey, we don't really know that. We don't really know that. It was kind of a, well, we could throw that into type piece of information.
In fact, because of its proximity to the sun as it went around, it did change its orbit slightly.
Yeah.
Right.
So it's going to be more than that.
It'll be 68,000 years before you see it again. So
Right.
mark your calendar.
Put that on my calendar now. Yeah.
Right. And then expected to be the brightest of 2023. I certainly hope not. I mean, and the anti-tail, as Gerald explained, is not something really rare. That's kind of what comets do, and it's not. So it was kind of annoying to see a lot of this, and there was some pretty strong opinions by some that it maybe does a disservice because it raises expectations beyond the reasonable. And why can't we just enjoy things that are just doing their thing, and why does it have to be hyped? Another one that came up around the same time period was about a week ago, maybe a week and a half, 2 weeks ago.
Yeah, something like that. Yeah.
A piece of the sun breaks off, and there's a picture of the James Webb Space Telescope, and then a picture of what they were talking about on the sun. Okay, so first of all, anybody who points the James Webb Space Telescope at the sun, that will be fired. That will be what I call a resume generating event. and you can point the James Webb Space Telescope at the sun, but you can only do it once. Right. And as we know, the James Webb Space Telescope is an infrared telescope designed to look at the farthest reaches of the universe, the most distant things that we could hope to see. It is not designed to look at a very hot nearby object, because that's way too much infrared energy for the instruments. And in fact, most of that telescope is designed to shield the instruments from the sun, not to actually accommodate pointing the telescope at the sun. So the James Webb Space Telescope had nothing to do with this observation, but it was an interesting observation. And what I want to do is, okay, so weather here on Earth is involves water and involves atmospheric currents. Weather on the sun is really all about magnetic fields. And this is an illustration of what the sun's magnetic field lines might look like at any given time. And you can see these white curly lines coming up off the sun and then descending nearby. And what that leads to is material from the sun periodically, and when I say periodically, I mean almost like daily, ejecting from the surface, following those magnetic field lines and curving back down, back into the sun. And that's called, solar weather, if you want. And every once in a while, you have a convergence of these magnetic field lines, and they become very tangled, and they become very powerful. And some of that material may eject from the sun, or it may travel great distances and form, in this case, form what almost looks like a tornado on the sun before the material descends and comes back down to the surface. And that's really what they saw. They saw something very ordinary. It was at the more maximum end of the scale of the ordinary, but it did not have to be hyped as a piece of the sun broke off and we saw it with the James Webb Space Telescope. That's not That wasn't necessary. It's actually just what the sun does, and it's led to some really beautiful photographs. Like this is fantastic. I mean, you could really see what was going on here, and a lot of amateurs in the Bay Area caught this as well. I don't have any of their photographs with me, but there were some really good ones.
Well, we might have seen that the other day. We had the Coronado telescope. It's a special solar telescope out on the deck, and you could actually see the prominences. And so, had we photographed it, we could have also claimed we saw a piece of the sun come up. But as Richard mentioned, it's a common occurrence. But talking about space weather, though, how is that related to what we see here on Earth in terms of the aurora borealis, for instance?
Well, the aurora is the interaction of the solar wind, basically ionized particles coming off of the sun, with the Earth's magnetic field.
Yes. Yeah.
Right. So it's a related concept, but it's involving our magnetic field, and other planets have auroras as well, caused by the same phenomena. Like Jupiter and Saturn have auroras, and very bright ones and huge ones.
Yeah, but I guess what I was going with that is, it's my understanding, maybe this is not true, Gerald, that if you do have a coronal mass ejection and it's pointed right at the Earth, because it could be anywhere on the surface,
you will get big auroras.
Yes, exactly.
That's because there's more ionized particles headed our way, and the larger the concentration of those ionized particles, the brighter and more extensive the aurora.
Correct. Right.
Very good.
And when you get a huge blast of those ionized particles, which is what happens when you get a coronal mass ejection that happens to blow in our direction, that can actually cause some problems on Earth. You can get this stream of our ionized particles, which is mostly deflected by the Earth's magnetic field. But when you get a really strong stream like that, it can actually penetrate into our atmosphere and cause disruptions of electrical power. That stream of ionized particles, it's electrically charged. And so when you pass that stream over power lines, it induces an electric current within the power lines that may disrupt electrical power. And so
it'll trip the breakers.
Yeah. So there have been a number of cases over the years where we've had one of those happen, and it knocks out power to large parts of the country, or, different countries, depending on where it impacts the Earth. So, but it's a normal activity. It's not anything unusual. Coronal mass ejections happen many times a year. There are periods when they're more likely to happen than less likely. There's an 11-year cycle for the sun, but they're not unusual.
And it's funny, and it's good you mentioned that, because actually this whole, it's always was a meme about this chunk of the sun breaking off. The whole thing started with a tweet from Samantha. No, her name is it Tabitha Skov? Or
Tabitha Stars?
No, she works with the Solar Observatory and does the space weather website, and is involved in putting out public information. Tabitha Skov, and she's here in California, and she always releases on a tweet or on the website or on Facebook anything interesting that's happening with solar weather. And it was just this innocent post that she put out where she was talking about this tornadic activity on this particular prominence and the size of it, etc. And then the media picked it up and hyped it to these, ridiculous levels, and that's how this whole thing started. And then there was other more responsible media that said, no, a piece of the sun didn't break off. It didn't really happen. But here's what actually happened.
And JWST was not looking at it.
JWST was not looking at it.
Colleen asks on YouTube, well, it's not actually a question. She just mentioned solar flare, ? So I think that maybe we can discuss the difference between a solar flare and a solar prominence, and a CME.
CME,
Yeah.
Yeah. Gerald, you want to
Hey, who's
take
gonna
that?
take
You
that
want
one?
to take that on?
Don't everybody jump at once.
Yeah,
Well,
Gerald, you
okay,
take that on.
It's just a matter of prominences. Richard was talking about the interaction of magnetic fields. These things cause spurts of ionized particles to shoot off of the sun's surface. Most of the time, they only shoot maybe a few hundred miles up into the upper atmosphere of the sun, and those are prominences. If you get a more dramatic one where it's shooting material much higher up, that's a flare. And then when it shoots material so that it literally leaves the sun and goes out into space, that's a coronal mass ejection. That's the simplified description. And again, these things happen all the time. There's also spicules.
Yeah.
Just a matter of how much stuff gets shot up into the atmosphere of the sun as the turbulence occurs in the sun's atmosphere.
And again, with our theme of everything being related, we are always looking at sunspots also. And sunspots
Yes.
are where bundles of these magnetic fields create what are called a flux tube, and where they enter the sun's surface, you get a sunspot.
Yeah.
Okay, a plug for Chabot here. If you come up during the day, quite often we have astronomers outside on our deck with little tiny telescopes that we call sun spotters, and they project a very nice image of the sun on a little background sheet, and you can actually see sunspots. It's kind of interesting.
And better still, what we try to do also is bring out. Well, actually, let me just mention from Facebook, somebody had asked, are there resources, educational resources for students? And a person mentioned a first grader. And I just happened to have been at Chabot this past Wednesday when we had a whole group of first graders as well as middle schoolers come through. And when the kids are coming up to Chabot, they are presented with regular science programs in the science center itself. But then they also have an opportunity to come up and see us on the observatory deck, where we oftentimes, weather permitting, will be viewing through two of our telescopes, our 8-inch refractor Leah and our 20-inch refractor Rachel. And on that day, we were viewing Venus through the 8-inch, and we were looking at the star Vega through the 20-inch. But out on the deck, we had a Schmidt-Cassegrain, an SCT telescope with a special solar filter, so the visitors and especially the kids could actually see sunspots, and we would explain what they were. And then on occasion, when we have an extra volunteer operator, we'll have a Coronado where you can actually see those prominences. So there's a lot there. But in terms of educational resources, though, we do have people at Chabot that have that expertise, and you probably could find out who they are in particular by looking up the website chabotspace.org and looking for the educational department. Unless,
Go
yeah.
ahead.
No, I was going to say, unless you guys have a specific person or a contact.
I was going to say that Chabot does daily field trips from elementary and middle school
Yes.
locations all around the Bay Area. So it's a popular place for them to come up and see.
Just throw out, we've heard a lot of statistics, but here's one that I thought was interesting. We had over 900 students this past week, over the past 3 days, that we normally see the school groups come in. So yeah, things are picking back up, and we're really happy to see the school groups back.
Mm-hmm.
We also do overnights, so you can look into that, where you actually spend the night at the observatory, go through all the exhibits. We do planetarium shows, and then you get to sleep in one of the exhibit halls. So that's an option too. All right. Well, let's see. A couple other things that I thought we could talk about. There was a new exoplanet discovered recently. And it's, well, we're discovering exoplanets all the time. Exoplanets are planets around other stars. And this particular one is called K2-415. And it's an exoplanet that was discovered by a Japanese astronomer, actually a team of Japanese astronomers. And they were using two different spacecraft. The Kepler spacecraft, which was launched back in the late 2000s, specifically to look for exoplanets. And then the TESS spacecraft, TESS stands for Transient Exoplanet Survey Satellite, which was launched just a few years ago to look for exoplanets. And these satellites, they look for exoplanets by observing stars and looking for what's called a transit. And when a transit occurs, the planet that's orbiting around the star happens to be in such a orbit that it passes from our point of view, or the point of view of the satellite, it passes between that star and the satellite, the camera on the satellite, and causes the starlight to dim a very small amount. And so these Japanese researchers were taking data that originally came from the Kepler mission, and they saw what appeared to be a transit of by a planet around a star that's about 72 light years away. They did some follow-up work using the TESS spacecraft and got the same thing. And when they crunched all the numbers, very interesting result. It turns out that this planet around a small star 72 light years away is almost the same size as the Earth. So it's very much an Earth-like planet orbiting around the star. It's much closer to the star than the Earth is to our sun, but because the star itself is so much dimmer than our sun, it's actually potentially in the habitable zone, and it's about the size of the Earth. I've got an image here that I'll share with you just to give you an idea what I'm talking about here.
Please, yeah.
These are data coming from the two spacecraft. This is from the Kepler mission, and then this is from the TESS mission. And what they do is they observe a star, and they're constantly measuring the output of the star, how bright the star appears. And they do this over a period of several hours. And when the planet transits in front of the star, it blocks some of the starlight. So you can see that all of a sudden the star dimmed for a little while, and then it brightened again. And by looking at how much it dims, how long it dims, and what the interval is between each time you get one of these dimming effects, you can tell a lot about what that planet looks like, how big it is, how close it is to the star, and so forth. So these are the data from the Kepler mission. You want to look at this top panel, ignore this other panel. That's just what we call the residuals. But this is the thing that really shows you what we're talking about. This is a transit method of finding exoplanets. This is the TESS data. The one down here, this is the data. I'm sorry, the top one is the Kepler data, and then this one down here is the TESS data. TESS is a little bit more precise in how they measure things. And they confirmed this exoplanet, and it got a lot of attention because it was an Earth-size exoplanet around a star 72 light years away. So it's one of the closest such exoplanets that we've found so far. We've actually found thousands of exoplanets, but this is one of the closest ones that was an Earth-like object. The star itself is a much smaller star than our sun. It's only about 70% of the brightness of the sun. It's less than half the size of the sun. And so it's what's called an M-class star. So it doesn't put out nearly as much heat. So if you want to be in the habitable zone, you got to be a lot closer to the star. And of course, the closer you are to a star, the faster you orbit around it. So, this is just an interesting find, and it's an example
Great.
of what's going on all the time.
You know, it makes. Go
I
ahead,
think it's
John.
worth pointing out, if you look at the numbers on the left side, how precise this instrumentation is.
Yeah.
It's just noticing a very tiny dip in the brightness of the star.
Yeah.
This is
very
really a great example on how the technology has progressed. I mean, 40, 50 years ago, we didn't know if there were planets around other stars, period. Right?
Right.
20 years ago, we knew there were planets around other stars, but we only knew about the ones that were the size of Jupiter and Saturn,
Yeah.
right? And here we are now finally detecting Earth-sized planets because of the improvement in instrumentation.
Yeah, I think I'd also like to mention on Kepler, I could be wrong about this, but I think the satellite has been somewhat crippled by
Yeah, that's why you see the K2 after the Kepler.
Right.
Several years ago, some of their light gyroscopes are for stabilizing the spacecraft and keeping it pointed in one direction. Some of them failed. So originally, the Kepler spacecraft could only point in one direction. It was designed to look only towards the constellation Cygnus. But when the reaction wheels failed, they could no longer do that. So they had to take advantage of its natural rotation. And that became, they sort of redesignated everything that happened after that as the K2 mission. It's actually not getting data anymore at all. But that's what you're talking about, John, is that failure of the reaction wheels.
Yeah, I thought that perhaps it was still being used, but I guess not.
Yeah, they finally...
They put it to bed finally.
Yeah.
Well, it did its job, that's for sure.
It sure did.
And the test mission was a follow-on mission, and it's much more sensitive. So, it's not like we stopped looking for them. We're just using newer equipment, So, all right.
Nice. How are we on questions?
Yeah, I'm not seeing too many on YouTube.
Right.
There's one user, it doesn't specify a name, but he says he's in Arizona, he or she is in Arizona, and missed seeing 2 planets near the moon. I'm not sure what.
Oh, yeah,
that's something very recent.
Yeah, that was.
Venus and Jupiter.
I got a question from the other day on my phone. Somebody just texted me a question about that. So the other night, or the last couple of nights, we've had a nice grouping of a young moon, of a sliver moon, which is called a young moon. It's right after the new moon, and Jupiter and Venus.
Right.
And there was one night where the moon was quite close to Venus, and then the night after that, quite close to Jupiter. And what was very interesting, and what got this other person pretty excited about it, was she was trying to figure out why the moon looked like it was almost like an eclipse, is what she said. And I was like, oh, well, that's very interesting that you noticed that. Because when you have a young moon, the geometry of the moon's illumination and the position of the Earth with respect to that creates enough Earth shine that it reflects back onto the moon, and the part that isn't directly illuminated by the sun is still visible as an outline. And that's what she was seeing. And it's always a beautiful effect. Yeah. And it was particularly beautiful with the bright planets nearby.
Yeah. And this effect was noticed a long time ago, hundreds of years, probably thousands of years ago.
Yeah, forever, right?
Galileo, I believe in the year 1610, he was one of the first ones to use telescopes to look up at the sky. And he noted this effect, and he actually drew it in his notebook. Of course, it was a pretty crude drawing, but it showed exactly that Earthshine on a thin crescent moon.
Yeah.
One of the interesting things is when you see a thin crescent moon where you just have a little sliver of a crescent, that means that from the moon's perspective, the sun is on the other side, mostly on the other side, and you're seeing only a small portion of the lit side of the moon. What's interesting is if you're on the moon, on the side of the moon facing the Earth, looking back at the Earth, when there's a thin crescent, the Earth appears to be a nearly fully lit object. So it's reflecting a lot of sunlight, and that's what causes that Earthshine.
Do you call that a full Earth?
Yeah,
Yes. yeah, sure. Why not?
yeah. When it's truly a full Earth, moon wolves howl at the Earth.
Moon wolves.
Hey, speaking of the moon, there was supposed to be a mission launch next month in March for a new lunar landing mission. It's called IM-1. Actually, the lander is called Nova C, and this was a privately funded lander. Actually, there's some NASA money involved in it as well. That was scheduled to launch in March on a Falcon 9 rocket. To fly up to the moon, go into orbit around the moon, and then eventually land on the surface of the moon. And it had several sensors on it that were going to, survey the moon. And this was done by a private company. They received a NASA grant to do this because NASA is trying to encourage commercial missions to the moon. Unfortunately, just within the last couple of days, some problems developed, and so they've now postponed the launch until June. So I was all looking forward to talking about it. I'm going to share an image here. This is what the lander will look like. It's got 6 legs, and it's got a bunch of cameras and other sensors on it. And this eventually will get launched to the moon, and it will land on the rim of a crater at the south pole of the moon. And we're very interested in the south pole of the moon because eventually when we send humans to the moon again, it's likely that they're going to go to the south pole of the moon because that's where we think the water is. Craters on the south pole of the moon, there are just a few craters there that because of the angle of the sun never shines down at the bottom of the bowl of the crater. And so comets impacting the moon would leave behind water ice within at the bottom of this crater, and it never evaporates, it never melts because the sun never shines on it. So it's always cold at the bottom of these craters. So we are hoping that will be a reservoir of water ice that future astronauts will be able to use for long duration missions to the moon.
Gerald, does this spacecraft have an orbiter component to relay back the radio signals?
I'm not sure about that. I don't think so, but I could be wrong.
Okay.
I know it will go in orbit for a while. It will be launched from the Earth, and then it will go into orbit around the moon, and then eventually it will land. But I don't know whether it's going to be communicating directly with the Earth, which wouldn't be too difficult, or if it's going to communicate through some kind of an orbiter. I kind of think it's going to be direct communication, but don't quote me on that. All right. And there's another lander. Actually, it's a rover that is being developed by NASA called the Viper mission. And the Viper mission will be launched later on this year. And it also will go to the moon, to the south pole of the moon. Only it's not just a lander, it's a rover. And it will travel from the rim down into craters and try to see if it can find that water ice also. if you want to see what the Viper looks like, I'm not going to show you a picture. You have to come up to Chabot to see it, because we have a full-size model of the Viper. Actually, we are a NASA visitor center at the Chabot Space and Science Center, and NASA Ames Research Center in Silicon Valley has actually provided us with a full-size model of the Viper rover, and you can visit it and see that and many other NASA exhibits at the Chabot Space and Science Center. There you go. I got another plug-in for Chabot, right?
You did.
That's good.
We've done a lot of that tonight, and
Yeah.
well deserved.
Right.
Yeah,
Absolutely.
somewhere in the audience is Mary Catherine France. She's Chabot's official PR person, and she's probably jumping up and down, going, "Go guys, go!"
Well, actually, just to mention that too, we do have that model, life-size model of the Viper. Space. It's not a spacecraft. What is it? It's
Rover.
It's a
rover.
lander.
The Viper.
Well, the Viper's a rover, right?
And anyway, the Viper rover model is in one of our exhibits, and you can see it. My sister was up visiting, and we looked at that. But what I really wanted to mention was part of the NASA display involves a wind tunnel, where you have the opportunity to create a little airplane and actually fly it in the wind tunnel. So I'm sure that there's some science behind it, but it was just plain fun. And my airplane flew the best.
You know,
I knew there had to be something there.
You've answered a question for me that's been kind of nagging me for weeks on why I've been finding all of these little paper airplanes
That's right.
all over the Science Center.
That's it.
And now I know why.
Yeah.
Yep.
All right,
Wasn't
guys.
me.
So
Alrighty.
I think that's it. Unless there's any other questions, we've been here for
hour and a
an
half.
hour and a half.
Hour and a half.
Yeah.
You know, I got one late question if we can
Go for it.
address
yeah.
it.
Sure, we have time.
So this,
Please, folks, if you've got questions,
I got
now's the
nowhere to
time.
go. It's snowing up at Chabot.
Yeah.
it's actually raining here too.
Yeah.
So Mark on Facebook had asked a question: can the James Webb Space Telescope detect atmospheres around Earth mass-sized planets, terrestrial type planets?
Yes.
Yes, they can. Not only can they detect them, but it can actually analyze the composition of those atmospheres. That's one of the primary missions of the James Webb Space Telescope. So the answer is yes.
And that is just amazing that they have that technology in space. I mean, think about it. What the type of equipment you need to analyze an atmosphere might be a mass chromatogram or a mass spectrometer. But to have that micro miniaturized in a package that is in space is just incredible.
Yeah. And if the Webb telescope detects a planet with, pollutants in the air and lots of greenhouse gases, it's obviously a advanced civilization planet. We shouldn't go there because they're just as bad off as we are. So,
One of those twins of Earth that was discovered by Star
Earth
Trek.
Who,
right?
yes, that's it.
yeah. Although for us here in the Bay Area, we've got bad weather. Obviously, we can't observe through the telescopes right now, but there are some cool things in the sky right now. If you happen to be somewhere where there's clear skies anytime in the next week or so, go outside around 8 o'clock or so and look high up in the sky for a bright yellowish orange star. And that is not actually a star. That is the planet Mars. Mars is in the constellation Taurus, the bull, right now. And with a small telescope, you can see it. There's not much to see because it's a pretty small planet, but it is up in the sky right now. Let's see, I think Venus is now high enough to where you can see it right after sunset. A very bright object in the western sky right after sunset. So you got a couple of planets to look at.
Yeah, right at the end of this month or the 1st of March, I think, Venus and Jupiter will be right next to each other,
Right.
right after sunset. So it's a good thing to look for.
Yeah, these are Venus and Jupiter are both pretty bright. So if you
Yeah.
look to the west right after sunset, you see what looks like two bright stars close to each other. That's Venus and Jupiter. And then a little later on, when it gets a little darker, look almost straight overhead. You look for that yellowish orange star. That's the planet Mars. Now, each night it moves a little more to the west. So, if you're looking a week from now, it might not be straight overhead. It might be a little more to the west, but it's very distinctive. It has this yellowish orange color. And then the other interesting object that's up in the sky right now is the Orion constellation, which is one of the easiest constellations to spot. It has more bright stars in it than any other constellation. And of course, it's got those three stars that are lined up nice and evenly spaced. That's the belt of Orion. So you want to check that out. If you got a pair of binoculars, if you look you'll see the belt, and then just below the belt, you see a much fainter string of stars. We call it Orion's sword. And if you take a pair of binoculars and look right in the middle of Orion's sword, you'll see a little fuzzy patch there. And that is the Great Orion Nebula. It's a huge cloud of gas and dust where new stars are forming. And, tonight, if we had been able to look with a telescope, we would have pointed it at that object. It's very interesting to see it in a powerful telescope. You can actually see some very young stars within it. You can see how ultraviolet radiation from those stars makes the cloud glow. So there's a lot of science involved there.
And to help you find it, if you look at the three stars in the belt of Orion, the one farthest to the left, if you're in northern hemisphere and looking at it, right below that is where the sword comes, and that's where to look. Right
Speaking of finding things, we got a question from Daniela who wanted to know how to find Polaris. Polaris being the North Star, and I'm going to share my screen here for a second because I went scavenging for the diagram I imagined and found it on NASA's website. Let me share this. So the trick to finding Polaris, or the North Star, is to first find the Big Dipper, because the Big Dipper is very recognizable. And if you find the Big Dipper, here's the handle of the dipper, and here's the bowl of the dipper, and of course it's upside down here in this rendering. You go to the two outer stars of the bowl, and you draw a line, and the first fairly bright star that line will hit is Polaris. And the rest of the constellation containing Polaris is the Little Dipper, but that's much harder to see. That you need to be in a dark sky in order to make out the Little Dipper. You have to go up to the Sierras or go up to Lake Sonoma or down to Henry Cove State Park or someplace like that where the sky is dark enough to make out the Little Dipper. But here in the city, you could see the Big Dipper. You could imagine this line, and you'll find Polaris that way.
Yeah, if you've got a good view of the horizon to the north, the Big Dipper most of the Big Dipper is what we call circumpolar. So the stars in it never set. They travel around the North Star, but they don't set. So you can, if you're far enough north, you can see it all the time.
Yeah.
Good question, Daniela. Right, guys? I think that's it.
Yeah.
Yep. Yeah, I think so.
Hey,
Unless anybody else wants to shoot questions at us, feel free. Now's the time. If we know the answer, we'll be glad to share.
Daniela asked another good question. Is there a map that shows where there is less light pollution? And the answer is yes.
Yeah.
And I will see if I could find.
Yeah.
There is. If you Google light pollution map, the first thing that will come up is a website called lightpollutionmap.info, and it will allow you to search for places and look at any part of the Earth and compare different regions, and it color codes the entire Earth according to light pollution. And you could zoom in great detail. So search for light pollution map, and it will give you what you need.
Unfortunately, it's getting harder and harder to find good dark locations to look at the sky.
Yeah. Most people have no idea what the real sky looks like. Especially people live anywhere close to cities. You get so much light pollution. You're lucky if you can see the Milky Way across the sky. And a lot of times somebody who has lived close to cities all their lives, they go on a camping trip or they go somewhere where they have a truly dark sky, and they're amazed at all the stars that are in the sky. There's thousands of stars up there that you should be able to see if it wasn't for all that light pollution. In fact, there is a great documentary film featuring a couple of famous guys from Chabot. The film is called Saving the Dark. Google.
Two of those guys happen to be on your screen right now.
Google Saving the Dark. It's a documentary film, and it tells you a lot about light pollution and the problems with light pollution, not only for astronomy, but for human health and for the welfare of wildlife and so on. It's a great documentary, and I would encourage you to check that out.
And there's also a new book that just came out on the topic. I was planning to pick it up today, but I'm not going to be able to do it till tomorrow. It's called The Darkness Manifesto. And it's written by Johann Eklof, that's Eklof, and it's on light pollution, night ecology, and the ancient rhythms that sustain life. And it's really talking about how we've altered the fundamentals of our planet's ecology by basically dumping light into the sky and having it reflect back down.
Yep. All right. Any other questions?
Now we could try to end with a picture we took through Nellie of the trapezium.
That's a much better. That's a much better idea than us ending with a song.
All right. Let me see if I have this.
Yeah. There you go.
So there you go. So this is
nice.
So this is the Great Orion Nebula with the trapezium at the center, right?
Yeah, and if you do venture up to Chabot on a weekend night, like a Friday night or a Saturday night, oftentimes we'll be looking at the trapezium in the Great Orion Nebula through Nellie, our 36-inch reflecting telescope. And while you can't see the color in your naked eye, this is what a camera will reveal in just mere seconds.
Yeah,
I think this image is about a.
This was 20 seconds, I think.
20-second image.
Yeah, if I remember.
Yeah. What's nice about this is you see a whole lot of the nebula itself, not just the trapezium in the middle, but all around it is a large gas cloud. Very cool to look at.
Yeah. Those four stars at the center are actually very young, very massive stars that formed within the cloud. Once they turned on, they started pushing the cloud away, and they've created a little pocket within the cloud, and we're looking into that pocket. But you can see that all around it, you have this glowing cloud. Ultraviolet radiation from those stars is actually ionizing the cloud and making it light up the way you see. It's pretty spectacular, and you can see a lot of it. You can't see so much of the color when you're looking with your eye through the telescope, but you can certainly see a lot of the detail that you're seeing in this image. So
yeah, and folks should realize that this was taken during one of our virtual telescope programs when it wasn't snowing. And so these are the types of images we try to do for you live when we're viewing through Nellie, and it's been very successful.
All right.
Alrighty.
Well, thank everybody for tuning in. Once again, we want to remind you there's that donate button that you see on Facebook. You can also go to the Chabot Space and Science Center website. It's chabotspace.org, and you'll see a donate button at the top of the website page. You can click on that. You can even join as a member of Chabot if you live in the Bay Area and get discounts on tickets and so forth. But we do need your support. We are a nonprofit, and so we hope you'll take a few minutes to make a donation or join as a member and help keep us going.
All right. Thanks, Gerald.
Alrighty.
All right.
And thanks,
All right.
guys. And
everybody.
appreciate everybody's participation tonight.
Yeah.
And we'll see you next
All right.
time.
Okay.
Alrighty.